Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. In this video, we write Java code solution for question 6 of ISC 2024 Computer Science Specimen Paper, which is to write this evil number class. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 1 or 2 are subscribed and a subscription is very important. So please do subscribe to my channel. So let's begin. So this is the question that we have to solve. Okay, so take a minute and give this a reading. So we are given this evil class, these are the data members, these are the functions, and we have to write a main as well. Okay, so I am going to start with an evil class evil. So the data members are num and bin, and num is a positive integer number, so I say private int num. Okay, making all data members private. Okay, then we have bin to store binary equivalent. I will take this as a string. Okay, the type for this is not defined, you can choose an integer as well, but constructing a binary equivalent into an integer will be difficult compared to constructing a binary equivalent into a string. Okay, because you can directly easily append zeros and ones to a blank string. Okay, in order to append ones and zeros to an integer, you will have to create the number. Okay, next is this default constructor. Okay, so I say public evil. Okay, so whenever you write class definitions in solutions of theory paper questions, make sure to make all data members private and all member methods and constructor as public. So I'm making this constructor as public. Okay, it says initialize data member with legal initial value. Legal initial value for an integer is going to be any integer. I'm going to take 0 conventionally. Okay, even if you make it 10, it's okay, but 0 is conventional. Okay, I will make bin to a blank string. Okay, moving on, we have void accept num. Okay, so I say public void accept num. Okay, it has to accept a positive integer number. Now in order to read an input from the user, I will need a scanner class object system dot. Okay, and I will have to do import java dot util dot scanner. Okay, I have to read a positive integer number into this data member num. Okay, it does not explicitly say that you have to read this to num, but this has to be understood in the context of the question. Okay, so I will write a prompt statement. Okay, enter a positive integer number. Okay, now this prompt statement is really not needed because the description of this function is to just accept a positive integer. But I am going to run this code and test this, so I want a prompt message before I am able to enter an integer. Okay, so the integer is read using scanner.nextInt and is stored into this variable num, which is a data member. Okay, and my accept num is done. Moving on, I have to find the binary equivalent of this decimal number using this function recursively. So public void recursive binary takes an integer x. It is, right? X. Okay, and you have to use recursion in this case. Correct. The two things to note here is this bin variable is supposed to store the binary equivalent of this decimal number, which is stored as an integer. The other thing that you have to take care is this process of converting integer to binary has to be recursive. Okay, so the only way I can think of it is this being the current integer value. Okay, so if my current integer value is 0, okay, so I simply append 0 to my binary. Okay, right, or you can take a digit 0, it does not matter because you can append integers to strings in Java. Okay, if this integer which is to be converted to binary is not 0, I find the remainder when this integer is divided by 2. So I say int r is x% 2. I append this to my current binary value, which is r plus. Okay, alright. So if you want to understand in detail the process of converting a decimal integer to its corresponding binary value, I have already posted a video for this. The link for that video I will add in the description of this video. Okay, you can check it out. But in short, what you have to do is keep dividing the integer by 2. Okay, and you append the remainders as you divide. So we append remainder to the left and not to the right, otherwise we'll get the reverse, okay, of the number that we need. Then we recur, this is the recursive part, passing x by 2, integer division of x by 2. Okay, moving on, I have void check, public void check. Okay, so I have to call this rec bin and display the result. Okay, making sure the function names are correct. Okay, all right, so I call rec bin with the given integer now. Okay, now when we call this function and this function returns, we will have the equivalent binary value in this string. So all we have to do is now count the number of ones in this string, and if number of ones are even, then this integer is an even number, otherwise not. Okay, so int num once is 0, iterate the string bin.length I plus plus. Okay, if bin.char I, the ith character is equal to a 1. Okay, we do now ones plus plus. If now ones %2 equal to 0, number of ones in the binary equivalent is even, then system.out.print num is an even number. Okay, else num is not an even number. Okay, and this is your even number class. Okay, in this case we will also have to write a main. Okay, so I'm going to write a main. So you can choose to write main in this evil class itself. Okay, but I'm going to write in a separate class, and again you can name this class in which you are writing the name anything you want. I'm naming it IC24 question 6. Okay, so public static void main string args. Okay, we create an evil class object calling the default constructor. Okay, so this is calling default constructor here. Okay, so the methods that we are supposed to call is first accept num, and then we call check. We don't call this from the main because this is already being called here in check. Okay, so the next call is going to be evil, the name of the object. Okay, dot check. Right, and this is your code. All right, quickly testing this. Java C. Okay, compiles Java question 6. Okay, so enter the positive number. I say 10. Okay, 10 is an even number, which is the case. Okay, you get a percent symbol here because you are not doing println. Let me just make this to println. Okay, compile, run 10. Okay, I will run with another case, say 20. 20 is also in an even number. I'll say 7, not in even number. So let me just find some way to print the corresponding binary as well. So I'll say num in binary. Okay, this is not a part of your requirement. Okay, this is just to check that whatever conversion we are doing from decimal to binary is correct. Okay, so I'll say bin. Okay, so I'll clear, compile, run with 10 first. 10 is 0 1 0 1 0. Okay, we are getting an extra 0. I'll tell you why. Okay, say 20, which is this. So 2 1, so it is even number, and I have 1 1 1. So 1 1 1 is basically this in binary, and this is an even number. And finally I do 7, which I get as 1 1 1. So now why this extra 0 even though your output is correct? Because if I have, for example, if I pass 0, okay, so 0 is an even number because number of ones are 0, which is even. If I remove this case, okay, I simply do return in this case. Okay, 0 will not be a valid binary conversion then. For example, if I clear, compile, and run. Okay, now if I say 10, the leading 0 is gone now. Okay, but if I say 0, I get a blank. which should not be the case. Okay, right. If I say maybe 20, leading 0 is gone. Okay, so the leading 0 does not make the difference in the number of ones. Okay, but to handle the case for this integer 0, I'm adding this 0. Okay, so that if you pass 0, okay, to be converted to binary equivalent, you should not get a blank string, you should get a string with a 0 inside. Okay, so this was the solution to this problem, and I hope this was helpful. So if you have doubts, if you have any questions, please let me know in the comments. I will also add the link of the code for this solution in the description of this video. You can check it out, and you can always let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. Thank you.